Okay, I think we're live.
Yay.
Hello, everyone.
Hello.
Welcome to our Hangout for Code Yourself. My name is Arati. I'm the course instructor,
And I'm Maria, and I'm one of the teaching assistants for the course.
and we're really excited to be here broadcasting live today from the Informatics Forum in Edinburgh. You might not be able to see, but it's kind of sunny, which is good. So, there are two sessions running this time. So we have two different groups of students following the course at different times. So Maria, do you remember which weeks people are on? So it's a 5-week course, yeah?
Yeah. So one of the sessions is in the last week, week 5, and the other session is week 2 of the course.
So I don't think we've had a hangout during the time that you've been following the course. The whole idea of the hangout is that we just come together, say hello, talk about things that are happening in the course and the discussion forums. What else do we usually do in the hangout?
We sometimes show some Scratch examples, some bits of code that you can use to create your own games or that you can play with.
And well, we're going to do that today as well. So we're going to build a simple but fun game. Oh, by the way, the occasion for today's hangout is also that this week is a European Code Week. So the European Union and Europe is celebrating coding. Which I think is a good idea.
It's a good occasion.
Maria, do you do a lot of coding in your working life?
Yeah, I actually do it every day because it's part of my PhD. I'm doing a PhD in informatics here at the University of Edinburgh, and my topic is about analyzing networks and comparing like social networks with road networks. And to do this, I program a lot of experiments in Python, and so I find it really useful to know how to code. And other people are using Java for their projects. I don't know what if you're using one of these programming
I'm
languages.
not. I'm actually using a language that is not that popular, but I think it's really cool. It's called Prolog, and it's a logic programming language. So I'm a big fan. So I do research here in the School of Informatics as well, and I'm interested in applications of artificial intelligence in healthcare. So one of the things I do is I work with clinicians looking at the pathways of care for different types of patients. So, for instance, breast cancer patients or HIV patients. So model those pathways and model the care process that the patient should follow. Analyze that as well and verify it. Make sure it's well thought out and there are no big errors, or that they conform to some guidelines published by clinical medical associations. And in order to do that, of course, you can sit down and look at papers and go through the medical guidelines, look at descriptions of what those care pathways might be, and argue about that. But I think it's very easy to miss things there, and you cannot provide guarantees that this is actually well verified. So that's where artificial intelligence and programming can come in nicely. So you can.
So it's a bit automating the
Exactly.
whole process.
It's about automating it. Yeah.
It makes it everybody's life much easier, I guess.
Hopefully, that's the plan. Hopefully, the patient's life too.
Yeah.
We'll find out. So yeah, this is just an example of the types of research that we do here. So what I described was quite different to what Maria described, and there are people in the school working on all different sorts of problems.
One of my office mates is modeling how animals move in their environment and how they interact and how, for example, disease spread. So this is something else that is very, I think, very popular area, and she's using Java for this to kind of build her simulations and programs. Yeah.
And there are quite a few people working on robotics as well in the
Oh.
school. We recently got, so I'm not a member of that team, but I know they've got some new
Fancy
equipment that we're very careful about here. There's also a new stream of work on data science. So I'm a bit involved with that as well in terms of teaching. So there's a data science initiative. We've got lots of PhD students working in that field. And there's a new doctoral training center for precision medicine. So again, data science applied to biomedicine and healthcare, which I think is pretty cool.
Yeah.
So, okay, maybe enough with the introduction of who we are, what we do, why we like. Did we say why we like programming? We didn't. How did you get involved in programming? That's I promise this is the last chit chat thing we're gonna do.
Well, we are taught programming in school, so we start learning I think C++ in the 7th grade, so about when we were 14.
Cool.
And yeah, I mean, at the beginning it feels like, well, you've got these algorithms and then you can do things with it, but it's maybe sometimes it's a bit difficult to see what they are applied for. But it's when you start building your own programs and your own games and your own, simulations that you really understand how all these algorithms come together. And yeah, it feels really good to have a little bit of code and then see that it does exactly what you're telling it to do. So yeah, I'm enjoying it a lot.
Does it happen a lot? Your code doing it what you want it to do?
Not most of the time, but eventually it always ends up like well, most of it.
So I'm asking because it's part of the programming process and experience. Things not going right. In my opinion, programming is a lot about problem solving. So tackling a problem that you want to solve in the real world, for instance, but also tackling problems within your code. So it does what you want it to do. The reason why I mention this is because many people that are new to programming can be put off by the idea that things don't go to plan or as expected all the time. And just to say this is completely normal.
Yes.
And it's part of the fun as well, I suppose. So once you figure out what bugs there are there and you correct anything that is not as it should be, I think you feel quite good.
Yeah. And it's a matter of trying to understand exactly how all the parts come together and try to split the whole algorithm in little parts and see which ones work, which ones, and then it's a whole process of it. It's
very good.
Yeah.
Well, I hope you follow Maria's tip on breaking big problems in smaller parts because that's the way to go in programming. Cool. So Maria, I think you've been looking at how things have been going in the forums as well,
yes.
right?
Yes.
So tell me, what do our students say? What do they like? What do you want to share?
Yeah, so for all the new learners, we're really happy when people say a little bit about themselves, where they come from, what sort of background they have. So far, we've got some learners from Greece, from Syria, from Saudi Arabia, from different places in the US. So it's really, really nice for us to hear how they're people from all over the world, and there are some people. They just recently moved to IT, and they have a very different background in this. Other people have done coding before, but they need a sort of reintroduction to how coding works and what are the principles of programming. So we've got
Excellent.
And I definitely encourage everybody to just say a few words, just so we know who you are and what made you decide to join the course.
So I think in these sessions, but also in the past, we've had quite a few teachers as well following the course. So computer science teachers, which makes me really happy. Because the whole idea of this course, it's a free course, and we want people to share and use our resources. So if you're a teacher and watching this video and you're not sure whether you could be using some of the examples we have in the course, please do. Please feel free to use them, modify them, make them work for you, and use them in the classroom. And there are different ways you could do that. So you could have your students follow the actual course, our 5-week course in the classroom, or you could just take some of the resources that we have, some of the videos, some of the quizzes or the projects, and just use them at your own time in class. There's a lot of discussion in education around what they call blended learning. So basically, this is a mixing kind of physical, face-to-face teaching, but also digital online learning. And I think using MOOCs or MOOC, online course materials is a good idea. So feel free to make use of the resources we have in the course. They're there for you. So anything that was any questions that were brought up or any discussions that were in the forums that you would like to talk about?
Yeah, so there were a few questions about specific Scratch instructions or
Okay.
how to deal with things. For example, someone was asking, so if anybody has encountered the problem that the motion script in the balloon party game has no blocks. So a good thing to remember when you change from backdrops to sprites, that the stage backdrop has no motion blocks. So if you realize that you don't have those blocks, then you probably need to press on the sprite so that you get back to the previous screen. And there was another question about if you draw a circle, for example, then if you just want to move to change its size, how to do this, because if you undo it, then the circle disappears. So one way to do it is if you select the circle and then you just resize that. Or a good thing to remember, as Heather, one of the moderators, pointed out, is to go in the vector mode, and then you can just click on the circle and resize that.
And that would be for permanently resizing the sprite, right?
Yeah, or the objects that you're drawing as well. And so another question was about how to verify if a sprite, for example, is touching another sprite. So what a lot of people do at the beginning is that they just put the condition, if touching the sprite, then do something. And as our moderators pointed out, it's good to add. The way to actually verify this is adding a forever block around the if statement, because this condition needs to be checked all the time. So if you only have the if block without the forever, then your code only checks once and it doesn't do it continuously. So that's a very useful thing to remember, I think, for future days.
Definitely, and it's one of the things that come up always at the beginning of the course.
Yeah.
Second week.
Yeah.
The balloon party is definitely where we bring it up. And I think what we mentioned in the videos is one way to think about it. If you put an if block inside a forever block, you can think of it as forever if. So whenever. So all the time, keep checking. Whenever I touch, the balloon or the red balloon, that's what should happen.
Yeah. That's definitely something to remember. And some users seem to have a few problems with Coursera on Internet Explorer or Mozilla Firefox. So it seems that this works as expected with Chrome. So if you can't go back to some resources, or you're just having general problems with the course, it's good to try Chrome as well and see if they're solved. So yeah.
So some of our students currently taking the course are on week 5, and some others are on week 2.
Yeah.
Now, if I'm not mistaken, on week 3 and week 5, we have 2 projects, the peer assess projects. So it might be worth talking a little bit about how peer assessment works and what you're expected to do. just so everything is clear. Do you remember, Maria?
Yeah, so everyone has to submit one project, and then the way it works is that the other learners in the course get a few of these projects, and they give a grade. They look over the code, and then this is how the feedback works. Yeah.
So this means you should also provide some feedback to your classmates.
Yeah.
So once you submit, I think, your project, you'll be able to see some of the projects that your classmates have uploaded, access them, and then there's an option for reviewing them. And there you're given specific instructions or things to look out for. So for instance, can you run the program? This is one of the first questions that we ask. Or for instance, on week 5, when we have the rocket and what was it? Objects to avoid.
Right.
So one of the questions I think is, does the rocket move or something like that? So there are very specific things, and then you can always give some general feedback in the end, which I think is very useful. Yeah. So imagine it was a friend of yours that built the game, the program. How could they improve it? What little things could you change so it works better than it currently does? Yeah. So it's good. It's a good idea.
Yeah, I think it's very, very useful to try to see what other projects people have been working on and how they thought about a certain problem, because there are always some differences. So it's just nice to understand the different ways in which you can think about.
Indeed, yeah. And remember to always upload your Scratch program. So I've seen this quite a bit in the past. You're expected, so you can create your Scratch program and save it on your machine or have it available on the Scratch website. In any case, you're expected to upload the actual file, that .sb2 file, the Scratch file, rather than provide a link to your publicized project on the Scratch website.
Right, yes. Just to make sure that everybody can download it and have it in there.
Exactly. So remember to hit that upload button, because we've had quite a few people mention in the past that, well, I went to review that project, but there was nothing there, so I couldn't really review it. So don't forget. Good. Anything else you want to talk about from the forums, or shall we move on to coding?
I think we can.
Okay, cool. So since it's a European Code Week and we're coding there this week, we've got a simple but fun game to build together with you. So the plan is I'm going to be sharing my screen. I'm going to be using Scratch, and I'm going to build a game where you have fish underwater, and you as a player can control a shark. We call it shark attack, by the way. Scary attack. So you're controlling the shark, and you're meant to, as a player, you're meant to chase different fish floating around and eat as many as you can. Scary times. So that's what we're going to do. So I'll try to share my screen if I find that button. There we go.
Maybe just a second.
I'm looking for. That could be the one. Yeah, the entire thing. Ooh, recursion.
Now the
Okay, so here I've got a new screen in Scratch. So what I'm going to do is, first of all, think about the different characters that we have. So I would like to have a shark. So I'll go here and go to animals. By the way, I'll try to explain things step by step and not too fast. Maria, if I go too fast, please slow me down. Okay, there should be a shark somewhere here. There it is. So we'll select it, and there it is on screen. And I'll also bring some fish. So I like this guy here. And there we go. And let's see, I'll bring, well, actually, I'll start with these two, and then we can be a little bit cheeky. I'll show you how. Cheeky, lazy, or smart? You pick. I say smart. So we don't want the cat, so I'll right-click on it and delete it. And still thinking about the design of the game. So these guys should be underwater. So I'll go and choose an appropriate backdrop. Let's see. There we are. So I'll go for this one here. Yay. Good. So the idea here is that this is the bad guy, right? The shark. And that's what the player is going to be controlling. If you have a look at the costumes for the shark, you can see that we've got a costume with a mouth closed, another one with a mouth open, and another one quite tired. I think I'll get rid of this one here. Our shark is never tired.
Always up for some meal.
And I want it to look scary, right? So we cannot have a fish being almost as big as this guy. So we want to make it smaller. Maria, you mentioned ways of making a sprite smaller. So could you remind us?
So one of them is to go to one of the little icons that says shrink. Click on that and then click on the sprite itself.
How
For example.
many times? So we'll have this guy quite small.
You can also, if you have more fish, you can also do that in code because there's a block that says set size to some percentage.
Cool. Good. So for now, we've gone for this approach.
Yeah.
We've got a little fish and a shark. The little fish has no other costumes, but that's not a problem. So what we want to happen here is that the player should be controlling the shark. How would the player control the shark? There are different ways. You could have the player controlling it with arrow keys, with the mouse pointer, with different keys on the keyboard and so forth. I'll go for the mouse pointer, just so we have it nice and easy for our players. So first of all, remember when we start a new program, we have to say how when the game starts or the program starts. So when green flag clicked. I'll try to make it a little bit more visible to you what is going on here. So I'll click on this button here. So they're nice and big, our blocks. So I'm now inside my small fish. I'm not going to think about the small fish right now. I'm going to think about the shark. So I'll bring another when green flag clicked block here. And what should happen? Well, first of all, we want to tell our shark what it should look like at the beginning, which costume it should have. So the way it's going to work is our shark will always have its mouth open, ready to attack the fish. And then whenever it gets closer to the fish, or whenever it's actually eating the fish, then it will close the mouth. So we'll go to looks, and we'll choose this block here.
And we need to
actually, before we do that,
yes.
How do we know what shark A and shark B is? And what does A and B mean? These are not meaningful names. So what I'll do is go to the costumes and give them better names. So I'll call it shark mouth closed. And this guy here is shark mouth open. Okay.
Yeah.
Now we know what it means.
This is actually very useful if you're writing code that other people will look at. It's so important that you give really good names for all your variables and all your functions. So
Indeed. And even if you're sure no other people are going to be looking at your code
even if it's for
ever,
yourself, yeah.
when you go and revisit your code sometime in the future, believe you me, you won't remember what A and B means. So mouth open, mouth closed is a better idea.
Right.
So yes, we're going to start with mouth open. So we're ready. Okay, now we're going to be controlling our shark with our mouse, the mouse pointer. So what we want to happen is that all the time, the shark should be moving towards the direction of your mouse pointer. So what does that mean? First of all, move. I'll bring that here. We'll take it step by step. Okay. Move 10 steps and point towards mouse pointer. Now, let's see. Actually, I'll put this because first we want to say what direction you should be looking at.
Right.
And I want this to be happening all the time, forever. I'm not sure whether it's going to work or whether the behavior is going to be as expected, but we'll give it a try. So now inside the forever block, I've got that the shark should always be moving towards my mouse pointer with this speed, let's say.
Yeah.
I'll plug it underneath and I'll hit the green flag to see what happens. Okay. Okay, that's quite good. More or less. But actually, well, first of all, I think it's going a bit fast. This way you're going to eat all the fish very quickly.
Yeah, we want to make it a bit difficult for
Indeed. And perhaps there's no need for the mouse pointer to be, so it's not that easy to control the shark. We can make sure it moves towards the mouse pointer or your cursor when it is at a particular distance from that mouse pointer. So let me explain. I'll use an if block, and I want to say if my distance to the mouse pointer is larger than the number, and we'll see what that number is, then point towards the mouse pointer and move 5 steps. So I'll bring those guys here. And this allows me to compare 2 values. Now, what are these 2 values going to be? Well, the first one is, it's got to do with distance from the mouse pointer. So where can I find that? I think it's in sensing. And it's this block here. I'm going to bring that in there. I have no idea what value should work. So I'll just try something, 10. And now remember we were talking about forever if, that's what we want.
Yes.
So all the time, we want to be checking whether the distance is bigger than this. And then if that is the case, keep moving towards the mouse pointer. Okay, let's see how that goes. I'll hit the green flag. Okay.
That's pretty good.
That's
you can
good.
see that now the shark doesn't keep rotating if it's
Yep.
next to the pointer. So it doesn't have that weird behavior when it just...
that we saw earlier, right?
Yes.
Yep. Excellent.
Oh, very
Good. So nothing happens when my shark is supposedly eating my fish, right? And that's because we haven't programmed it. So let's have a think about that. Okay, what we will do is think about what the fish does. So here we've got the beginning of our program. Initially, I'm not going to think about how the fish might move. What might make sense is to say, okay, what will happen when I'm eaten by a shark, or what does it mean to be eaten? So, Maria was mentioning earlier that touching a particular color or touching a particular sprite, right?
Yeah.
So basically, the fish is eaten whenever it's touching the shark, or whenever it's touching that blue color of the shark. So we want to be checking all the time. So forever if again. Now, what is the condition? Let's see. It was about sensing, right? So touching color, we could use, let's see what options we have. We could use touching color, or let's see here, or touching a particular sprite. So I think it makes more sense to go for that one. Let's see. And what should happen if it's touched by the shark? Well, initially, just to test it, I'm gonna have the fish say, no! So this is just for testing purposes. The actual game is going to be a little bit more interesting. I'll hit the green flag. Okay, it's been eaten. Okay. Now, remember we said we've got the shark with the mouth open at the beginning, but then when it's actually eating that little fish, it should close its mouth and open it again. So somehow this little fish should tell our shark that it's been eaten.
Right.
So a very handy way to do that in Scratch is by using broadcasting. So I think that is one of the control. Or not. Was it events? Yes, it is. Excellent. So, what does broadcasting mean? Do you remember, Maria?
It means that whenever a part of the code is testing if something is happening for one sprite, then it lets the other sprite know what was happening. So in this case, if the fish is touching the shark, then we can let the shark know that there needs to be that he needs to do something about his action.
So it's basically communication between different objects in our program.
Right.
Excellent.
Because we have individual bits of code, so we need a way to make them communicate.
Yes, good. So now we've still got our fish saying no, and then broadcasting got me. So something should happen on the shark's end when the shark gets this message. So let's see. First of all, we need to get that message, right?
Yeah.
So if you look at the events here, there's this block. So remember, we're inside the shark's code. And now we're coding the behavior of the shark when it eats or when it's just eaten a little fish. So what should happen? First of all, it should close its mouth. There's another idea too. We can make it make a sound.
Oh, that's exciting.
Okay, I'll go and have a look at our sounds. I don't remember what pop is.
Maybe you can check the sound library for.
There we are.
Yeah.
Now I remember there's one that should work really well. It's this one here, chomp.
Chomp.
Good. So I'll bring that in.
Okay.
Okay. I'll get rid of the pop sound. And I'll go back to my script. So what happens when my shark eats a little fish? It should make that sound. So I'll go to sounds and play that sound. But also it should close its mouth and then open its mouth. So the way to do that, remember, we've got different costumes for that. So we can have switch costume to first close the mouth. And then I'll bring another one, open the mouth. Maria, what is it that you don't like? Tell me. Shall we give it a try?
Yes.
Before we give it a try, tell me, what do you think is wrong here?
I think there might be something missing between these two, but we can see how it goes.
Okay, I'll give it a try because I cannot wait. Okay, so now we're going to test our eating behavior. Okay. You're probably right. What is it that you think we need to have between those two blocks?
Maybe we need to just wait for a bit in between switching from one costume to the other, because otherwise you can't really see the change.
That is a very good idea. Maybe 1 second is quite long. I'll go for 0.6. I don't know. We'll give it a try.
Yeah.
Okay. Let's try again. Yay! Okay. Let's see. Okay. All right. I might get it a little bit shorter, the waiting time, just to see. So I have to say, this is not the behavior exactly that I was expecting. So it just takes a little bit too long. So what I'm going to try is, instead of, let's see. So when is my fish being eaten? Instead of using touching shark, I could try something else. Okay, this is just us trying things out, okay? It might not work. I'll try with a color.
Yeah. Or maybe color is touching a different color.
Okay, cool, yeah.
So we can check if the color of the shark touches the color of the fish.
All right, good. So if the color of the shark, so first of all, I'll click here. This is the color of the shark. Is touching the color of the little fish. I'll go for the purple one. I know, now that I was looking at the code, I know what else is a bit strange. It takes quite a bit for this guy to broadcast the message. Okay, before we go and change the color behavior, I'll keep using the previous condition that we had there, just out of curiosity. And I'll first get this guy to broadcast the message, "You got me," and then say something for 2 seconds. Let's give that a try.
Oh.
Okay, that's better.
That's much better.
Yep. Okay, cool. Good. So this is us showing you live that things might go wrong, but you can definitely fix them. So this was one of the workarounds we thought, because we didn't realize why it was not behaving the way it should. Now we've got it, so I'll get rid of this guy just by leaving it there. Cool. So let's see. So far, our game is not that difficult because we've just got one fish that is just there all the time.
Yeah.
So one idea would be to make the fish float, swim around. But before we go ahead and do that, I would like the fish, instead of it saying no, to make it disappear. So it's like
the shark is actually eating.
Yeah, it's been
the
eaten.
fish.
It's gone. Goodbye world.
Oh, poor little fish.
Okay, make a goodbye world, but just for a few seconds. Okay. So I'll get rid of this this guy here, and if you go to looks, there's a show and hide block. So we'll get the fish to hide initially when it's eaten, but then it will reappear after a few seconds. So after a few seconds means we'll make it wait for a bit, let's say 3 seconds, and then show it. So that was in looks. Now, before we go ahead and test it, whenever you use these commands that change drastically how your objects appear, it might be worth thinking about what they should look like at the very beginning of the game. So at the very beginning, what do you think, Maria? Should we have it shown or hidden?
Well, I think we should have it shown.
Okay.
Just so we know. So the shark has it a bit easier.
Okay. Bit of a doubt there. Okay, my little fish, you should be shown at the beginning. And then whenever you're touched by the shark, so whenever you're eaten, you'll tell the shark that you've been eaten, then hide for a bit, just a bit, and then come back again. Okay, let's try that.
Oh, yay! Oh, there it is.
Oh, okay, cool.
Good.
Now, see, it reappeared at the same spot. So what we could do is tell it to reappear somewhere.
Just a random spot, maybe. On the
Okay,
screen.
yep. So, Maria, do you remember how we can do that?
Yeah, I think if you go to the motion section, then you will see that there's a block that says go to a specific position. So you can move that one after show. Well, maybe that's not a good idea. Maybe it's before show.
Okay, yes. Why?
So if you put that block after show, then the fish will first appear at its initial position, and then it will suddenly move to a different one. So we don't want this. We want it first to move and then to show.
Good thinking.
Thank you. And
how about the random thing?
Yeah, I think maybe in operators you can find there was something about, oh yes, pick random. And instead of one of the positions or both of them, it's up to you. You can choose a coordinate for X. And
so let's see how we can get a sense of our coordinates. See, when I'm moving my cursor here on the stage, that these numbers down here change.
Yeah.
These are the coordinates where my cursor currently is.
Right.
So I suppose some good numbers would be, somewhere centrally, but not in the very center. So say minus 200 to 200. Yeah.
Yeah. So if you're looking for the X coordinate, you're basically choosing the vertical, the horizontal position of your fish. And we can either keep the vertical one fixed, or you can choose another one. It depends on how.
I say we go random. So why being random?
Okay.
And I'll go again for, I think it should be minus. I'll go for minus 150 to 150 this time. Okay. Let's try it. I'll hit the green flag. Okay. Ooh. Good. It worked.
Nice.
Cool. Now, see, when I stop the game, you cannot see the little fish. That's why we've put that show block there. So when we start it again, there it reappears. Yeah. Cool. Excellent. Now, I'll get rid of the say no block because, well, it's just dead for a few seconds. And remember we said we wanted to make the fish swim? That's what we're going to do now. So we're going to make it move?
Yeah, we already have the forever block, so we just need to add a few motion blocks inside. So first, just move.
Inside the forever block.
Yeah.
And
we can see how this looks for now.
Yep.
Oh.
Okay. Oh, yes, I know. If on edge bounds, that's one of the first things we use when we've got continuous movement.
Yes, because otherwise it'll just keep trying to go right. And we wanted to.
Oh, now,
Not exactly
okay.
what we want.
Let's see how we can fix that. When it bounces, it turns upside down. The way to correct this is by, remember, clicking on that icon here,
Right.
and choosing that middle option. Let's try. Okay. Yes. Excellent. Now, I think it's moving a little bit too fast.
Yeah.
Okay, so I'll go for, I don't know, 3. Let's see what that looks like. Okay.
Yeah.
It's a slow game for now, but we can.
It's the beginner.
Yeah, it's the beginner level. Okay. Now, currently,
Yeah. Our fish is just moving left to right. Maybe we can change this a bit.
yes. So we can introduce turning, maybe.
So that it's a bit more difficult for the shark to.
And I think we'll use again a random number of degrees, because this way it's going to be a little bit more interesting. So I have no idea what numbers it should be. So let's see. That's quite nice, actually. Let me play a bit more. See what happens. Okay. And let me try negative numbers, just out of curiosity. Okay.
Yeah.
Ah,
This actually looks quite a bit like a fish.
quite a bit. Okay, cool, good. That's closer to what I had in mind, actually. Yeah.
Good.
Let's make it move a little bit faster. Just a little bit. There we go. Okay. Now, what else should happen here? Let's play the game that we've got so far to see what happens. Okay, it's been eaten. It reappears. Ooh, eaten again. Okay, there we go.
Good.
Cool. Okay, that's very close to what I had in mind. But I have to say, just one fish, it's not a very challenging game. So we could just bring more fish like this.
Right.
One way to do it would be to use cloning. But since this is one of the things we'll cover later on in this course, for the ones that are currently in week 2, I'll be cheeky or lazy or smart. You want to call it, whatever you want to call it, that's us. And we'll right-click and duplicate. Now let's see. And it's got the same code in there, so that's quite nice. I'll duplicate that too. How many would you like to go for, Maria?
4.
4. Okay, then.
Okay.
And in order to make it look a little bit different, for one of those fish, we could use a different costume. So we'll go to costumes and bring another fish costume here.
Yep.
That could be a special fish in some way.
Maybe if the shark gets that fish, he'll get more points.
That
In
is a
more
good idea.
advanced version of the game.
So I'll shrink that too. This is a cool fish. Yeah, can't be bothered.
Yeah,
So
maybe we want to. We don't need to remove the other costumes.
well, I don't think it's a bad idea to remove it. We don't really need it.
Yeah.
So it's nice to keep things
Here.
yeah, tidy. So there we are. Cool. Let's give it a try. Okay, we've got our shark. Now let's have a look at the shark. See, when I go and press my red button, my shark always goes to that direction because that's where my cursor is going.
Right.
I don't like that.
Yeah.
So what do you think we could do?
Well, for example, we can go to initialize the position of the shark for something specific, like
Cool. Well, that's what I'll do. Tell it to start at a very specific location. Let's say it starts here.
Yeah.
And that is minus 95. Okay, I'll go for minus 100, 100. Let's try it out. Ah,
yes.
cool. Ooh, 2.
Oh, they're appears again.
Ah.
We need to get rid of all of them at the same time.
I'm on it. Okay, cool. Nice. Okay. Well, this is just a very simple game that we've programmed in less than half an hour. So that just goes to show what you can do. I'll stop sharing my screen now and talk about ways we can make it. Oh, yes. So, how could we improve this game, right? Right now we've got a shark that you can control as a player and 4 different types of fish. Well, 4 fish, one being different, floating around and being eaten by the shark.
Right.
Any ideas how we could extend this further? Make it a little bit more interesting.
I think there are many, many ways we can do this. For example, we can have a timer so that, let's say, we need to eat all the fish in less than a few minutes, or we can have a counter for how many fish the shark has eaten, a score for different fish, for example.
Yes, I like that.
Yeah. So since we had the special fish, I think we should definitely offer more points for that one and maybe make it move faster so it's more
Good idea.
able to catch.
Good idea. Excellent. What I like with games, and actually this is mentioned in one of the interviews that we have with that game programmer from Uruguay. I think he's from Uruguay. So he mentions that you somehow need to keep your users or your players entertained so they get hooked with a game. And if it's a very simple game, that's not going to work. If it's a terribly difficult game from day one, again, that's not going to work. So having different levels is a good practice.
Yeah. So it's good to start with a simple idea and then try to build on it so that you get different different input.
Yes, yeah. And one of the things that he actually mentioned was the element of surprise. So perhaps when you move to a new level, you could have things that were not present in the previous ones. So, you have a new challenge as a player. So for instance, in one of the first levels, we could have just those 3 fish that look the same. And then in a level later on, we could have the guest star, that cool looking fish.
The big fish.
So that's just an idea. Good. That's more or less what we wanted to show you in terms of live coding. We've got a few more minutes left.
So one of the learners, Tyler, he was asking on the forum about what would be the next steps to learn other programming languages that give you more freedom to do real world applications. And the question was, I think, about game development. So I think in general for that, object-oriented languages are maybe the most suited for that. And I think a good thing to keep in mind is that there's this cross-platform game engine, which is called Unity. So this is definitely something that you could look at, and it'll help you develop games for Windows and for mobile platforms and all of that. So
cool, great. In terms of next steps in general, so many people ask what kind of programming languages or what language would you recommend learning next? And again, there are many languages out there. What would you say, Maria?
I think it depends a lot maybe on the application, but two languages that are very common and commonly used by many big companies and in industry and research as well, they're Python and Java.
Mhm.
I think so. Probably Python might be a bit easier to learn as the first programming language. Well, after Scratch. But yeah, I think they're both very good candidates.
I couldn't agree more. That would be my answer as well. So yes, either Java or programming would be really, really good next steps
Yeah.
in your coding experience. And I do agree. So Python might be the most kind of natural next step, but it also depends on what you want to do.
Yeah.
So for Tyler, for instance, Java might have been a better
Yeah.
option.
Yeah, I think so.
Cool. Well, great. We're almost reached, I think, the end of the session today. I hope you enjoyed it. I hope you've tried the Shark Attack game. If you want to try it at home, feel free to extend it and enrich it. And I'm very curious to see what kind of variations you come up with. So in that case, please do upload your games on the Scratch website and let us know through the forums. I'd really like to play your games.
Me too.
Okay, well, good to see you. Hope you enjoy the rest of the course and keep coding.
Yay.
See you later.
Bye-bye.
Bye.
See you.